Hello, everyone. In the previous session, we explained what we mean by statistics and the different presentation of data and the shape of a data distribution when we explained when the shape is we can say that the shape is negatively skewed, symmetric, or positively skewed, and we focused on the bimodal distribution. Okay, so we will continue in this session to apply what we explained before in numerical examples. So we are here. Okay, we'll start by this exercise with a back-to-back plot, stem and leaf plot. So the heights in centimeters of the boys, okay, the heights in centimeter of the boys and girls in year 9 class are shown in the back-to-back stem and leaf plot. Okay, comment on the shape of each distribution. Normally, when they ask us to comment on the shape of each distribution, they ask us to say if the shape distribution is negatively skewed or positively skewed or normally symmetric. Okay, so how to find this? We know in the stem we can look from up to down, okay, or we can rotate a little bit. We can rotate 90-degree to the left our plot to obtain this form here. Okay, like we see here in the left, what we see. Stem is positively oriented in this way, and for us, yes, for the numbers or the data or the different heights of girls is positively like we from down to up. Okay, very good. So the smallest number is 149 centimeter, and the greater number is 17 and 173 centimeter. Okay, so our plot is correctly oriented. So how to comment on the shape of this distribution? So like we see here, we have a tail and the left. We have a tail. Okay, if we plot the curve on the top of we have tail on the left. So the distribution, girls' height distribution is slightly negatively skewed. Okay. So how to see or how to comment the shape of boys' heights distribution? We have boys' height distribution in this way. How? We flip this plot upside down. Okay, we flip it upside down to have boys, okay, to have boys first. Normally here a stem is correctly oriented, 14, normally 15, 16, 17, 18, and we have here 4, and yes, the smallest one is here, and the biggest greater heights are, or the biggest heights of boys is 18.3, so 183 centimeter. Good. So for us, we can plot or okay to obtain this curve with tail on the right. We have tail on the right. Okay, we have tail on the right. So the boys' heights distribution is slightly positively skewed. Okay, This is a trick to comment correctly a back-to-back stem and leaf a plot. Okay, so how about the range? The range. Okay, let's refer to the original. Okay, to the original plot here. Okay, range, it is the difference between the smallest and the biggest number. So about concerning the girl's heights. Okay, the smallest is this one. Okay, and the biggest is this one, because we are on the right of the stem, so we are oriented in this way, from left to right, from up to down. Okay, so for us, the smallest is here, and the left of the top, and the biggest is located on the right and down to the right. Okay, so the smallest is 149 centimeter, and the biggest is 173 centimeters. So normally the difference is 173 minus 149. We will obtain 24. Okay, about the range for boys' heights. So normally the boys are located on the left to the stem, so it's oriented in this way and from top to down. Okay, so normally the smallest number is to right, top on the right, and the biggest one is down to the left. Okay, or to the left. Very good. So the smallest number is 15.4, 154. The biggest one is 18.3, 183 centimeter. So 183 centimeter minus 154, we will obtain 29. Okay, what about the median? What about the median? We should erase everything here, everything. Okay. What about the median? Normally, the median, by definition, okay, it is the middle number, the middle data in the list, the middle one in the list. So normally it depends from the number of the data. Okay, the data number. So concerning the boys' heights, we have 1 height, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. We have 15 different height, boys' heights. Okay, so 15, it is a odd number. So how to deal with odd number of data? We add 1, 15 plus 1. We add 1 and we divide it by 2, we obtain 8. So normally the data or the height located in the position number 8. How to know the position? Because in the stem leaf plot, the numbers, the data is well arranged from smallest to the biggest number. Okay, how? Like we said before, for boys is from left, from right to left. Okay, from top to down to the bottom. Okay, how? So we compute in this way: 1, 2, using this arrow, and next 3, 4, 5, 6, 7, and 8. So this is the median for boys: 1, 70, 1, 17, 0, 170 is the height for boys distribution. What about girls? For us, we are on the left to the stem, so the arrow is positively, or the number are positively increasing in this way and from up to down. Okay, so in the same way, we have 15 different heights for girls. So 15 plus odd, 15 plus 1, 16 over 2, 8. So the median is located in the position 8 in the list. So 1, 2, 3, 4, 5, 6, 7, 8. 8 for us. 8 is here. 16, 8 is 163. Okay, so the median is 163. What about the mean? The mean is the average. The average is given by this expression. It is equal to the quotient of the sum of the heights in the list over the total of the number, or the total of the data number. So we know that we have in each list we have 15. So the total is for us 15. We will divide the sum by 15. Okay, so we have in total 15, and the list of different heights for boys is 15, 4, 154, 154 plus 15, 6, 156, 156 plus 16, 2, 16, 2, 162 centimeter plus so on to finally add 18, 3, 183, 183. Okay, we'll add these different heights and we'll divide it by the total of data that we have in the list of boys distribution, height distribution, to obtain 169.4 for a centimeter for the boys. The average, the mean is 169.4, and similarly we can compute the mean for the girls distribution to obtain 162.9 centimeter. Okay, so we will this is we achieved, we finished this exercise, and we will continue to have the last one, where the data here, the data is given by a stem leaf, back-to-back stem leaf plot. So when we have a grouped data, well organized in tables, how to deal with this, with these data. Okay, we have here two different teams, team A and team B, where we mentioned, we indicated the number of goals per match. Okay, here we don't have list and grouped data, we have grouped data well organized in different tables on table. Okay, so scored by two soccer teams. So we have two different soccer teams, team A and team B. Okay, and here we have in the first column the number of goals of each team, 0. We have 0 goals in 4 different matches. Okay, and we have 1 goal, or in 7 match we did a one, the team A had 1 goal. Okay, etc. So display this information in back-to-back histogram. Normally here we have back-to-back histogram, so we have bars. We don't have stem to leaf plot. We have histograms, we have bars. But what we mean back-to-back? Back-to-back, it is a way to compare in one histogram or one plot. We compare the 2 different teams. So we have in common the number of goals. Yani the first column is common between the 2 teams. So we can, like, where this the first column is common between the 2 teams, so we can suggest that this column can be considered as the vertical axis to us. What we mean by the vertical axis. Okay, so I will continue. So I have one problem here. Okay. Okay. I will have. Okay. So good. I fixed the problem. I opened another, the other PDF where I don't have that solution. So I will continue on this one. Okay, so we have the first column in each table is common, so we can consider it as the vertical axis. Okay, the vertical axis where the number of goals are indicated 0, 1, 2, 3, 4, 5. And each side will have the bars, horizontally bars, for team A and team B. For sure, the height of each bar is equivalent to the number of match. Okay, so number of match. So we can consider, for example, each centimeter, 1 centimeter, for example, it is a match for us. So 1, 2, 3, 4, 5, 6, 7, and we should not miss any number. Okay, we should have the same scale on each side on the horizontal axis, which indicates for us the number of matches. Okay, so the bars should be equivalent to the numbers. For example, 2 goals for team B, 2 goals for team B. Team B, 2 goals. We have 5 match. Okay, so five. It is the height of the histogram is 5 here. Okay, very good. So it is very easy. Okay, they ask us also to plot another one, a parallel dot plot, dot with point. Okay, each point represent for us a one value. Okay, for us, always we consider the first column or the first row. If we have a row table with rows, here we have a table with columns. Okay, the first column we considered as the horizontal here, because a parallel dot plot, we have a plot for each team, and we don't have a plot, a common plot like we have in the back-to-back histogram. Okay, so number of goal is horizontal axis, team A, and each plot for us. So vertically, we considered the number of matches. So normally for team A, we have 2 goals in 1, 2, and 3 different matches. So yes, 2 goals for 3 different matches. Good, good. And we can plot the dot plot for the team B. How we can comment about the shape distribution of team A and team B? Normally we can based on the plot the dot plot of each team. Normally here we have if we take by curve the top of each dot, each bar of dots, we obtain like a tail on the right, so it is positively skewed. Okay, and same as for the team B. The team A is positively skewed and team B is slightly positively skewed. Okay, what about mean? Okay, how to compute the mean when we have a grouped distribution? A group distribution, we are in case different from the list distribution where the data is ungrouped. Here, we should know that we want to add, we know that the mean is the sum over the total. The total of what? Okay, the total of matches. okay? Because we have here, for example, 4 plus 7, 11 plus 3, 14 plus 0 plus 1, 15 matches. So عندي in total 15 matches, okay? We have 15 matches. Total that want to divide the sum is 15. So, so what about the sum? The sum of what? The sum of the multiplication of each goal, number of goal by the its frequency. Frequency, the number of repetition. Okay, how many is repeated this number of goals. So we should multiply 0 by 4 plus 1 by 7 plus 2 by 3 and etc. I mentioned the remark here with grouped. It is particularly for the group distribution. Okay, sum of the product of each value by its frequency over the total frequency. We mean by the frequency the number of repetition. Okay, the repetition number. So mean of team A, I calculated, we obtain 1.13, and the median, how to obtain the median, also we have 15 frequency, 15 different matches, odd, so 15 plus 1 over 2, it is equal to 8. How to obtain this list? How we can obtain this list? Like we can write in any case, we can write the table as a list. How? 0 is repeated 4 times, so 0, 0, 0, 0. 1 is repeated 7 times, so 1, 1, 1, 1, 1, 1, 1. Okay, 7 times, like we see here. So the median is located in the position 8 for us, so is 1. Okay. Range the biggest value minus the smallest. Biggest 4 minus the smallest 0, so 4. In the same way, we computed in team A, B, the mean, the median, the range. I think, in my opinion, when we compare the different mean and the median, when the mean of the team B and the median of the team B is bigger than, greater than the median and the mean of the team A, so we can say that team B is perform better than team A. Okay, and the last exercise I want to apply or to explain how to apply mean, median, range on lists. Okay, on list we have a list, so they ask two different lists of grades of a test, geography test for girls and boys in year 9 class. Okay, draw a back-to-back stem and leaf plot. Normally, when we want to draw a back-to-back stem and leaf plot, we want to arrange increasingly the values of different grades for girls and different grades for boys. Okay, we arrange the list. First, we obtain this list from the smallest grade to the greatest or to the biggest grade on geographic test for girls, and this for boys. Like we see here, we have a 9, 9, 1, 2. We should choose correctly the stem. We have 9. Normally, all the grades or the numbers or the data are composed of 2 digits. So the third digit, we should fix it as stem. Like 9, we have before 9, 0. So 0. We have a 12 here, so 1 is the digit that we can fix it as a stem. 2, we can fix as 22, and etc. to have 5 in final stem. For girls, we want to put the grades of girls on the right, on the boys on the left, or you can choose the location that you prefer for each one. Okay, for girls we have 099. So we want to know that for girls that we can step from smallest to biggest in this path. Okay, from left to right, from up to down. Okay, so 090909 12, 1 2 12, 15 1 5, 17 1 7, etc., to obtain our back to back stem and leaf plot. Okay. If we see clearly the shape of its distribution by flipping, by oriented the plot to see clearly, so the girl grades distributed is almost symmetric, but the boys is negatively skewed. Okay, so what about the median? We have list of 15 grades odd, so the median is on the position 8 in each list. So 26 is the median for girls, 35 is the median for boys. Okay, what about mean? In the list, we have the frequency indicated in the list. We don't have here frequency. The number is repeated, but in the table, in a grouped data, well organized in a table, we have 9 one time and the frequency is 2 because it's repeated 2 times. For this reason, we multiply 9 by 2. Here, we add all the different grades, 9 plus 9 plus 12 plus 15, and we divided by 8, 15. We divided by the total number of grades, 15, and we obtain the mean. Here we can say clearly, after comparing the mean and the median, that the boys perform better. Okay, thank you for listening. This is all we need to know for today. I'm waiting for any of your questions. Bye bye.